Hi, this is Irv Shapiro with Make with Tech. I haven't made a video recently, been concentrating on some other things that you'll learn about in the future, but a unique opportunity came up to make a video. When I'm done reviewing 3D printers, I generally donate them to nonprofits, to community organizations, to local schools. Once in a while, I provide them to friends of mine. So I posted on a community group recently that I had some printers I wanted to donate, give away. Somebody reached out to me. Their son was going to be in charge of a 3D printing group within a overnight camp. And they had an Ender 3 at home that he had been practicing on, and it stopped working. They couldn't use it. And so they wondered if I have a different printer he could practice on. Well, I asked them what was wrong with their printer, and I told them to bring it over because we probably could just fix it. Well, it ends up there was a surprise that I missed for at least a couple hours, but in the interim, I completely tuned up their printer. I adjusted everything on their printer, and then I discovered the solution to their problem. So stay tuned and let's learn something together. So the printer we're going to look at today is a SainSmart Ender 3 clone. I think it's just an Ender 3, generic Ender 3 with the SainSmart label pasted on the front. And it looks very much like any other pretty much first or second generation Ender 3. I haven't opened it up to see exactly what the control board is inside. But it's a very good printer to learn on because you have easy access to all of the components. That's one of the things I like the most about the first generation Ender 3s. So we're going to go through this printer and do some tune-up, and then we're going to solve the original problem. The original problem is nothing would stick to the print surface. So I assumed in the beginning it just wasn't leveled properly. They assured me they'd done it many, many times. I thought, okay, I'll try it myself and we'll see what happens. When they brought it over, there was filament that had broken off just inside the extruder area. And so to get it out, I needed to disconnect the coupler here that is used to hold the Bowden tube. So I explained to them, you just push in on the coupler and then you should be able to pull it out. And you can see this one came out easily. However, with their original Bowden tool and coupler, it was completely stuck. So I unscrewed the coupler using just the wrench that Creality, or in this case SainSmart, provides you with their printers. It was still completely stuck. So I said to me, you know what, I have a piece of Capricorn tubing. Capricorn Bowden tubing is a higher grade of tubing. That means two things. It means the internal diameter is more accurate and it's able to handle a bit higher temperatures. So this blue tube here is Capricorn tubing. How did I replace it? Well, I just used this wrench to unscrew the couplers on both ends, both at the hot end and the coupler on the extruder. Now there's a trick with Ender style 3D printers. There are two types of hot ends. This is the overall hot end assembly. One type is a hot end assembly where the Bowden tube actually goes all the way down to just above the nozzle. So it goes all the way down inside. If you do not push it firmly all the way down, your printer is going to jam repeatedly. So when you take off the Bowden tube at the top here, by disconnecting it here, once you have that loose, before you attempt to pull this out, you have to heat up the hot end. Why? You have filament going through this Bowden tube into the nozzle area, and I'm going to go to control, to temperature, and I'm going to set the nozzle to about 220 degrees Celsius. Now, depending on your filament, you may be printing at a lower temperature, but I want to get it good and hot to make sure it doesn't stick at all. This is up to temperature now. So now I can take and pull this component out. You'll see it was hot, right? Now, alternatively, we could have just pulled out our filament first, and that would have been fine. Now, I'm going to turn this back off, and you'll notice that this Bowden tube is coming down fairly far. Then I'm going to use a little trick. I'm going to release the coupler, slide it up. Then I'm going to take the Bowden tube, I'm going to push it into the hot end as hard as I can. You need to make sure it goes all the way to the bottom. Then I'm going to slide the coupler down, and I'm going to start tightening it. If this does not tighten easily, then you may have cross-threaded it. So make sure it's started nicely. You should be able to even turn it the first couple turns with your fingers. But then we're going to tighten it all the way down. Now you don't want to ever crank anything hard. You want everything to be sort of finger tight. That means as tight as you can get it, pushing with one finger. There we go. Now let me attach the other end. That's going to slide back in here. And this is less critical on this end. Make sure that's finger tight. And we're good to go. Now, you'll notice the Bowden tube is attached to the electronics cable with some wire ties. And then you'll see this little thing on here. You know what that is? That's a badge holder. You buy them in any stationery store, big box stationery store, online. And it's just a great way to keep the cables out of the way while they're printing. So I've just replaced the Bowden tube. What's that going to do to my printer? Well, if the tube is a more precise size, the retractions and extrusions of the filament will be more precise, and the filament will flow better. Okay, but that's not the reason my friend brought this over to me. That was a side effect of trying to get this to work. And here, by the way, is their old Bowden tube. And if you look at it, it's very distorted on the ends. So this might have been holding the filament a little too tight. They said that prints weren't sticking. So how do we address that? Well, the next thing we're going to do is we're going to level the print bed. And I'll show you on these early printers a sneaky way to do that. So these are Post-it notes. I'm going to take a Post-it note off. I'm going to fold it so that the sticky side is stuck together, and it's just the right thickness for leveling the printer. So there are 4 knobs under your printer. So when you make them looser, the bed moves up because there's a spring that expands. When you make them tighter, the bed moves down. So we want it so that when you put this under the print head, there's clear tension on the paper, but it doesn't rip. So how do we get the print head to the 0 position? Well, in these early Ender printers and on a lot of entry-level printers, there's a little switch. Hear that? And when the gantry hits that switch, it's in the 0 position. So if you have a single threaded printer, not a dual threaded printer, but a single threaded printer where there's one Z-axis, single Z-axis thread, you can turn that by hand slowly, not too fast, until it just clicks the switch. Hear that? Okay, now, so I'm going to put the print head over this corner, right over where the screw is. I'm going to put the paper underneath and go to the 0 position. And then try to move the paper. I can't move the paper at all. So that says this is too tight. So I'm going to tighten the screw. Tighty, righty, lefty, loosey. So I'm going to turn it to the right until I can just move this paper. Okay, now I'm going to raise this up. I'm going to go to the next position. Same thing. little too tight. Good. Now I'm going to go to the next position. That one was about right to start with, and I'm going to go to this position. That feels about right. Now I'm going to put it in the center. Okay, now I'm going to tell you a secret. When I first did this, the corners were all fine, but the center was a little too loose. So what did I do? I stuck a Post-it note under the print surface, right in the center. That's going to move the center up just a little bit. It ends up that a lot of these early, inexpensive Ender style printers, the center is not quite right. So you can use a Post-it note to make that adjustment. Okay, so now that this is adjusted, I can go ahead and try to print. So what did I do next? Well, I tried to print using the default Cura settings for PLA. Nothing stuck. I'm thinking, you know, I've done this before. I'm pretty good at it. So I took out something called Magic Glue. Magic Glue is a print bed adhesive that gives you a little bit more latitude about how perfectly your print bed is aligned. I tried it again. Still nothing stuck. I'm thinking, what's going on here? So the next thing I noticed was that a lot of things were loose on this printer. The belts were loose. The print module, the print head system was loose. There was a little bit of play. So I decided I'm going to tighten everything up next. Okay, so the belts on this printer are controlled by these two bolts right here. You loosen them up and then you can slide that out and tighten them down. And you want to get that pretty much as tight as you can make it. The belts on the bottom are controlled by these bolts down here. Same thing. You really can't make them too tight on these printers. So pull it out. Once again, finger tight pull it out. You don't want to be muscling it. Now, how do you stabilize this print head? Well, under the print head, I'm going to show you a picture, is a special nut called an eccentric nut. It's a nut where the hole is not in the very center, it's off center. So as you rotate it, there's a round base on the back, so as you rotate it, it will move in or out. Very interesting design. So that's how you adjust these wheels. When you turn these wheels by hand, the print bed should move, the print head should move. Even if you're holding the print head, you should not be able to turn these by hand with the print head not moving. If you can, this eccentric nut underneath is too loose. So put the wrench that you got from Creality or your print manufacturer on that eccentric nut. So I have that on there now. So I'm going to loosen this first just to show you. And now you'll see, yeah, that loosens it. Now you'll see that I can turn these more without the print head moving. So I need to tighten that up. So I'm going to tighten it up. And that'll make sure that this is not going to move up and down. Now you want it once again finger tight. If you make it too tight, these wheels will wear down too quickly. Likewise, there's eccentric nuts that control the wheels on the bottom under the print surface. You also want to take and control those. Then I'm ready to try it again. Let me show you how I try it. I turn on the printer. I go to any website and find a print bed leveling print. Now, before I do a test print, obviously I have to put my filament back in. So I'm going to mount the filament on here. I'm going to cut it off on a nice sharp angle so I have a good point on there. I'm going to load this filament into the extruder while pressing the two buttons together so that it just aligns with the Bowden tube. And I'm going to press it in until it comes to a stop. Now it will not extrude now. Why? Because the print head is cold. So I'm going to go to the front of the printer. I'm going to go to Control. Let me turn this so I can see it. Temperature, nozzle, and I'm going to turn this up to 220. Okay, this is up to temperature now, so I'm going to squeeze the spring on the back so that the path is nice and straight, and I'm going to push on the filament, and we should see it should extrude nicely out of the front there. Now I'm ready to do a test print. So I'm going to go to Print from TF Card. I'm going to select the print bed test. Now I'm going to start it printing, and we'll see if it sticks properly to the print surface. And now it's printing what's called a purge line. That's a line just to make sure the filament's flowing. And see how I'm rubbing my finger on it? It shouldn't rub off. If with a light rub it comes right off, it's not adhering properly. Now it's printing a skirt, which is an area around my print. And you can take and look at it as it prints, and you can see here it's not sticking at all. Now I can take and unscrew each of these knobs a quarter turn. That will move the print surface up a little tighter, and we'll see if that helps. So even while it's printing the initial skirt or even your print, I'll get this other filament out of the way, you can attempt to continue to fine-tune the printer. So if I loosen these, it's going to move the print bed up a little more. We'll go even a little more. And now we're seeing that it's a little better, but it's still not working properly. So my next thought was that the print temperature calibration was not working properly. That means the thermistor, the thermostat in essence, the thermometer that's measuring the temperature, wasn't calibrated properly. And the way you calibrate that is by doing what's called a PID calibration. Let me show you quickly how to do that. So I'm going to take my cable. I'm going to open up my Chromebook, and this could also be a laptop. I'm going to plug it into the USB-A connector and plug it into the printer. Then I'm going to go to a website called 3D-printing-tools.makeWithTech.com. And I'm going to show you this on the screen. Now, the feature we want to use on this site is called Terminal. So I'm going to click on Terminal, and I'm going to click Connect. And if I have the cable connected properly, when I click Connect, it should say USB serial. Now, if you're on a Windows machine, it'll say like COM3. On a Mac, it does say USB. So it'll depend on your device. So we need to connect to the USB device. And you'll see a display down at the bottom. What's happening is those are display messages coming from the control board on this computer. So as an example, I can type in, I'm going to click on uppercase commands and reverse log just to make it easier, because many printers you have to send the commands in uppercase. This will make it automatic. I'm going to type in M115 return, and what this just showed me was the version of the firmware on this computer and what the basic settings are set to. Now, to turn on PID calibration, if we look down here, we'll see that to calibrate our hot end, we type in M303E0 and then a temperature. So I'm going to type right up here, M303E0, S for the temperature. That's calibrated for 220 degrees. Hit a return. and you'll see here it says auto tune started. Now what it's going to do is it's going to tell the printer to go to a specific temperature. Then it's going to measure the temperature it actually gets to. And it's going to keep doing that over and over using a sophisticated algorithm in order to determine how accurate the measurement and heating system is. And then it's going to give me a series of numbers to enter back into the printer so that it's properly calibrated. So let's let this finish. Now while I was waiting, I just noticed that I had a post-it note right here on the side of this printer that said M301. The 301 command is the way you put the numbers back in to set them. And P, I, and D, as in PID, those are the numbers we're going to set. We'll see here it says auto tune finished and what the values are that we should put into our configuration file. So I'm going to take and enter some values here. M301, then P 30.39, I 2.52, D 91.48. It said OK. Now I can do an M500 and that will save it in this printer. If I don't do the M500, when I turn the printer off, it's going to go back to the other values. So this should be calibrated properly. So I went ahead and I made another test print. Still didn't stick. I then put on some Magic Goo. Magic Goo is a bed adhesive that makes things stick better. Still didn't stick. I'm thinking, I've done this literally hundreds of times. So then I'm looking at the filament my friend brought over. It's from eSun. It's one of the new PLA Pluses. And I see here on the front, it says temperatures 205 to 225. Typical PLA is 180 to 220 or lower. So that's probably why it wasn't sticking. So I went and I resliced at first layer 230. Print bed 65. Future layers, print bed 60. And then at 210. And let's see what happens. So we're going to go ahead and start the test print. Okay, it's setting the home position now. It's printing a purge line. The purge line is sticking very nicely. Won't this be interesting? Maybe I didn't need to do all this work. It was good to learn anyways. It was good to do. But maybe it was just temperature. And now it's printing the skirt that's going to print around my print. And it's sticking better, but it's not perfect. So I'm going to raise the print bed a little bit more by going about a quarter turn on each of these. And let's see if it's sticking better. Oh, much better now. Actually going to go a little bit more. And that's one of the nicest things about these Ender 3 printers is with these big dials here, you can adjust it as it's printing. And now it's actually sticking quite well. If I rub my finger over it, it looks like it's right. The bead looks relatively round. I want to flatten it out just a little bit so I can go a little bit further up. And remember, tighty-righty, lefty-loosey. And so if I tighten it, it pulls the bed down. If I go to the right, if I go to the left, it moves the bed up. And now it's sticking perfectly. But once again, it's still a little bit round. You want the bead to be a flattened bead. You don't want to see it breaking up like it's having trouble printing, sort of like drawing with chalk on a sidewalk. You don't want it to have that look. But you also don't want it to be a completely round bead. You want it to be a flat bead. And this looks like we're in good shape now. So it's wonderful that I did all of these adjustments. I tightened the belt. I adjusted the temperature with the PID adjustment. I adjusted the wheels with the eccentric screws. I changed the Bowden tube to a higher quality Bowden tube. You'll notice I have this little thing here. That's just a very simple thing. That's a badge holder. I use it to keep the cable out of the way. They sell for, I don't know, 10 bucks on Amazon. And now we can see that this print is printing very nicely, including in the center, because I put a post-it note under the center. So folks, sometimes it's the simplest thing. Check the temperature of your filament. But today, we learned how to maintain and support an Ender 3 style 3D printer. Thanks for watching. Please subscribe to the channel. Recommend it to your friends. Share this video. Have a great day, and let's continue to learn things together.